as we already know how to plot multiple lines onto the same graph, so these two graphs are easy to plot because basically the function we're going to use is plot, and then we just need another three values. So the remaining question is, how did we create such values? Stay top 10, stay top 25, stay top 50. And this plots just plots different numbers out of bottom 10, out of bottom 25, out of bottom 50. So the essence of these two graphs are the same. Let's focus on the graph at the bottom. Okay, let's focus on these three values. How did we create these three values? Here we go. So first, we will set a specific ticks. Say, let's look at the value when the ticks equals 1,000. Time 1 equals 1,000, which we define here. Time 1, now it's 2,000. So time 1 equals 2,000. When ticks equals 2,000, we run the functions, we execute the lines here. First, we will calculate the median value of the wealth of all turtles. So for every turtle, we get the wealth. And for all this wealth, we will find the median value and assign the value to Matt. And then, looking for the turtle with value greater than median value. So this is the top 50% of the turtles. And then we take the median again. So now this median is the top 25 threshold. So similarly, we can get the bottom 25 threshold using turtles with wealth below Matt, and then take the median value. With Matt up, we can multiply 90 and divide it by 75 to get the top 10% threshold. And we use Matt down, multiply 10 divided by 25, we can get the bottom 10% wealth threshold. Okay, so now we have all this threshold for the median of the whole population wealth, the 25 threshold for the whole population wealth, the bottom 25 threshold, the top 10 threshold, the bottom 10 threshold. And then we can change the size and the color for the top 10 richest agents and the bottom poorest 10% agents. We make the rich red and the size 3. We make the poor blue and the size 3 as well. And then we will keep track, we will make a record of the top 10 richest agents. We save that number, we save that account into the variable total top, and we save the bottom 10% of turtles. We save that account to total bottom. And then after the ticks beyond 2,000, we will keep track for every tick to calculate the median, the top 25, the bottom 25, the top 10, the bottom 10 values. And then we will count the total number of turtles who will belong to the top 10% when the ticks equals to 2,000. And also, the same turtle should also belong to the current top 10% turtles. So to satisfy these two conditions, meaning that the number of turtles satisfies these two conditions will be less than the number of turtles who satisfy the top 10% of the richest turtles at ticks 2000. So this is a ratio below 1. Similarly, we can calculate the ratio for the turtle who not only belong to, at the time 2000, belong to the group of top 10% richest, and also their wealth at this moment greater than or belongs to the top 25% of the wealthy turtles, divided by the total top, which means what is the percentage of the turtles who maintained their wealth belong to the top 25% of the population. And similarly, for the 20%, stay their wealth belong to the richest 50% of the population. So this way we can guess these three values for every tick. And then we can use a plot function to plot the value at every tick. Therefore, we get this graph. And similarly, we can guess this graph as well.